Okay, so I will be solving a Bernoulli equation. So the first step, we would have to create our equation into the standard form for a Bernoulli equation. So there's an x here, so we would divide by x. So I'm just going to divide the entire thing by x. That would turn into dy dx plus 1 over xy is equal to xy squared. So our next step would be divide by y to the n, in which case our y to the n is negative y to the second power. So divided by y to the second power, we get y to the negative 2 dy dx plus x to the negative 1 y to the negative 1 is equal to x. So from here, our substitution is going to be u is equal to this. So moving on, we get u is equal to y to the negative first power. We derive, we get du dx is equal to negative y to the negative second power dy dx. So when we go to substitute onto this, we see that these two terms are all very similar, except this one has a negative and this one is positive. So we switch the signs, we get negative du equal dx equal to positive negative second power dy dx. So now we're ready to substitute our terms. So this becomes negative du dx plus x to the negative 1 u is equal to x. So now with all that substitution, we have transformed, or with the Bernoulli principle, we have transformed this equation into a linear differential equation. So now we can solve it with our integrating factor. So our integrating factor, our p of x, is this term right here, our p of x. We get e to the integral of x to the negative 1. So that becomes our e to the natural log of x. Oh wait, I forgot to carry this negative. Forgot to carry the negative. So yeah, I apologize. Because this was negative, we had to switch the signs for everything, so to make it positive and put it in the right form. So instead of this being negative du, we multiply by negative 1 to get positive du, negative x, negative x. E to the natural log of x become, with the negative on the end, becomes x to the negative 1. That's our integrating factor. This is our mu. So plug it into our formula. We get x to the negative 1 du dx minus x to the negative 2 u is equal to negative x over x, which just becomes negative 1. So integrate both sides. We recognize that this is the product rule. So then it becomes the integral of the derivative of x to the negative 1 u. And the integral of negative 1 is equal to negative x plus c. I'm going to erase my board a little bit. So x to the negative 1 u is equal to minus x plus c. So we get rid of this by multiplying by x. We get u is equal to negative x squared plus cx. Now, we gotta get rid of our y, or we gotta substitute back in, so this becomes 1 over y is equal to negative x squared plus cx. So, solve for y, times y, divided by term negative x squared plus cx. So y is equal to 1 over negative x squared plus cx. And that is a solution to a Bernoulli equation.